Thank you, Douglas, for that reminder always. I think we are now recording. Cool. So I have this here. Can you see this? Is the handwriting clear? Wait, I guess.
Not seeing it just yet on my end.
Yeah.
Yeah, now, now I can see it.
Cool. Great. So is the I don't know how well you are able to see it. Hopefully we can zoom this in here a little bit. Okay, so let's think about the array methods that you know. What are some of those array methods that you know?
Filter.
Filter.
Dot slice.
Slice.
Include.
Includes. What else?
Map.
Map. So I'm actually going to put them here, actually. Let me, there are sort of two categories. So I'm going to put them like, I'm going to put them here, some kinds. So we said slice includes. I heard somebody say map. Somebody said reduce. What else?
For each.
For each.
Splice.
Splice.
Sort.
Every.
Wait, I think I heard two people, but I can't understand. Cameron, was one of those you? Every. Every, that's correct. That's one. What else?
Sort.
I think that person a little bit louder.
Sort.
Oh, sort. Yes.
Join.
Yeah.
Join.
Split.
Is split an array method?
No.
Why not?
It's a string method. I forgot.
Mm-hmm. What does split does?
It splits a string on a given character.
Mm-hmm. Turning it into an array, right?
Yeah.
Or the result is an array. Okay, so from here, we have higher order functions. I'm gonna color this a little bit differently, maybe. From here, higher order functions are these guys. Wait, let me just make sure that we didn't forget any of the ones that I had here. Yeah, no, we got them all. These are higher order functions. What does it mean?
Fill as well, right? Fill.
There's fill, yes, but I think fill is not as used. There are a bunch of array methods, but I think this covers the most important ones. The ones that I have in red are specifically called higher order functions. Who knows what they're called higher order functions? What does that mean?
Is it because they require a callback? Or that's, I mean, something like that? It's been a little while.
Let me see why they did this color change. higher order. No, I keep changing the color. It is related to the fact that they require a callback. But how could we, let me just type this quiet callback. And I think I ran out of space. Right, a higher order function is any function that as an argument or as its input takes in another function. So in this case, those functions, those arguments that we pass on to those other functions, we call callbacks, right? That is a specific term, or this is the way that we call it in JavaScript. In Swift, they call it closures, for instance. A function that goes into another function that you pass on to another function, it's called a callback. For us in JavaScript, in Swift, is called a closure. Let me erase this. Takes in a function. We call that a callback. Okay, so let's go back here. So from here, filter, map, reduce, for each, every, and sort, all those are higher order functions because they take in a callback as its argument. When you call the function, instead of passing a number, a Boolean, or an object, you pass in another function. Okay, so we get that sort of out of the way. We know that the argument to these functions is another function. Let me change this. The argument is a function. We're gonna see some example of this. Let's start with for each. So this takes in a function that I'm just abbreviating as fn. Okay, so for each takes in a callback function. What are the arguments that get passed to that callback function? Peter. You could press your space bar to talk, like a walkie-talkie.
So for each takes in an array, and it goes through each instance of the array, and does what the required function is.
I think that's close, but not the most accurate language. I'm talking about the function, the function that you pass on to for each. For each doesn't take in an array. For each takes in a callback function. You say array that for each. The array is like on the before. You do something like callback example. I guess we'll do something like array that for each. And here, in this parenthesis, we pass in something. What is, when we were talking that we pass in a function, right?
Which you want every element to be referred to as? Like that?
Right, so here, we pass in a function here that I'm gonna do just an anonymous function. What are the arguments that go here?
That's like the name of what you want each instance of the array to be called.
That's correct. Here you get the element that the for each is iterating over. So the arguments to the callback is the element. So I'm gonna just call current element. CRL. So if we have an array of numbers, let's say let 1, 2, 3, 4. I need to erase this here. Let's call these nums. And we have then here, instead of array, let's say we have nums. Nums dot for each. If we have this example, let me make this a little bit bigger. In the arguments of the function, we get the actual num, or the current number, whatever you want to call it. And then we can do, that is our argument to our callback. And then from there, we can do anything we want with it. We want to console log it, etc. Okay, so we said the arguments to the callback is the current element. Anything else besides the current element? This is the current element is what is going to be passed onto the function, onto the callback function. What else does the for each receive any other argument?
Can be the index.
And it can also have index, right? As Min mentioned here, we can have the current element that I call num. We can also have the index. And so on. There is another one that is the array. There's a third argument that it could receive, that is the array itself, where the for each was called. That one is rarely used. Just because the array, if we put the third argument, the array would be just actually nums as well. So that's sort of, if you wanted to have access to nums within the for each function, you could use that third argument. Most of the time, because we already have like nums here, and it's sort of in the scope, then we don't really need that one for anything. Cool. So the callback arguments are the current element, and I'm just going to call it I for the index. Cool. So an example of a callback is the one that we drew here. I'm going to draw another one here. Like in ES6, let's call it like num. Where we just console log. I think this is going to be too short. Where we can just console log num. But this is an example of a callback. The argument that we're using at all, also the arguments to your callbacks, you don't need to use them all. Like here in this example, I'm just using the current element argument rather than the whole thing. Okay, what does the callback function that goes into the for each return? Does it return anything? Should it return anything? Sergio, what do you think?
I think it returns. It returns an array.
The callback?
No, it returns.
Yep.
Well, it does one. I think it does one return for each index number.
Well, it could do that, But in actually here, the callback, I'm gonna say the return value is ignore actually. So it doesn't matter if the callback function returns anything, the return value is just ignore it. The return value, even if that function is returning, like instead of, let's say like instead of console log, we had like return none, that would just be ignored. Nothing happens, and even if it returns an object, if it returns true or false, that is just ignored, right? So the callback, it can return, but it's just gonna, it can return, whether it returns or not, it will be ignored. We're gonna see how that matters for other methods.
Yeah, I was thinking about like when you return for each element of the array, you return something. That's the only return you get.
Right, but in this case, for each doesn't have to return, and if it does, the return value just gets ignored. Nothing happens with it. Now, okay, so that's the return for the callback. What is the return for the for each as a whole? Let's see. Amin.
Yes, it returns undefined.
Undefined.
Don't have any return, yeah.
This is important. Sometimes returns undefined. So for each is a function that we can use in arrays to execute another function, execute a callback function for each element in the array. That function doesn't have to return, the callback doesn't have to return, and if it does, it's ignored. And as a whole, for each returns undefined. So for each doesn't return anything, it returns undefined, right? And we're gonna see how that gets compared to some other cases. So let's bring this here. Put this here. Let me create a new file here. So we do, actually, in a bit, we're gonna see them. We're gonna see them here. Actually, let's do this small example. So for each. So remember, here we got the num. You can call it current element, or generally we call it. Generally, arrays have plural names, right? And here we use a singular name, meaning a member of the numbers array. So if we do console.log, now let's say for each return, and let's do console. F return. Just so we have it. Let's put this here. So I have node array methods. So we can see here how we are executing this callback function for each element in the array. And we can see that if we try to store the return value of for each into a for each return, we just get nothing. We get undefined. We don't get nothing, we get undefined. It doesn't return anything. This callback function, just for context, this callback function could be actually a separate thing. Here, let's call it like lognum. So I have my lognum function there. and I can just pass that here. I don't have to write it in. I don't have to write it in the arguments. Oops. Undefined is not. Undefined is not a function. Wait, what did we get here? Line 5. Anybody sees the error? For each. Oh, I guess I forgot to save. There we have it. We still have the same result. The callback function can be written anywhere, and we just pass it there. As I was saying, and this is true for all of them, the second argument to the callback here is the index. So we could do, let's maybe console log the current element, or the index followed by the current element. And we see index 0 has number 1, index 1, number 2, etc., etc. Cool. Questions about this?
Me, I don't understand what's happening in that code.
So let's revisit it. So we're calling for each in the nums array, right? The job, let's actually read here the description. Here it says, performs a specified action for each element in the array. I will say, what I will change this to will be call the specified function for each element in the array. And what is our specified function? Our specified function is the log num function. So this is saying for each number inside of nums, call the log num function, right? And the log num function is this function that we have here. Let's break it down into multiple lines.
Why is it saying, why is it executing that function and then giving you undefined?
That's correct. So if we look at the log num function, that is just console logging the index followed by the current element, and that's this part here, right?
Mm-hmm. Yeah.
The other part is this console log that I have here, and this console log I just put to show us that for each doesn't return, it returns undefined, and I saved the return value of this expression. I saved it in the for each return, just for us to see that for each doesn't return anything, or more accurately, for each returns undefined, and that's what I wanted to prove here, sort of with this console log. If we remove that, we're just going to see, whatever the log num function did. But again, this is just to demonstrate that for each returns undefined. Sometimes we're going to see that makes a little bit more sense with compared to some of the other methods that do return something. Is that a little bit more clear?
I'll wait and see the other examples.
Cool. Mm-hmm. Yeah, I think the others will provide a little bit more context. Other questions? Oh, yep. I think, Douglas, I'm not having trouble listening. No.
Hello, can you hear me?
Yep, now I can hear you. So maybe let us know at a later point. Okay, so let's take a look at some of the others. So from here, let's move on to map. What is the argument that we must pass to a map function? What do we pass to an array dot map? Chuck.
A callback function.
A callback function. That's correct. So I'm just gonna say function here. Just like to all of these in red, we're gonna pass a function. What are the arguments for that callback function?
Want me to answer that as well?
That will be great.
Cool. Like basically an element to like an element to basically indicate every single element inside the array.
Mm-hmm. Right, that's what we call the current element. Or if we go to, let's take a look at, yep.
No, I was interrupting you, my bad.
If we go here to the documentation, I think let's see what they call it here. They call it the current value. So the callback arguments, or in this case, they call it parameters, take the current value, the index, and the array. So, so here, that current value, I'm just calling the current element. Let's put it here, current element, as well as the index. This is going to be true for most of them. They take in the arguments to the callback will be the current element, the function is iterating over, and the index. Also, like all these functions, filter, map, reduce for every sort, they have a loop underneath that somebody wrote. That's why for each was able to call our function for each element in the array. We could just do with for loops, like we could do all of this stuff with for loops. They were created just because they're really handy to have, because they're repetitive tasks when you're filtering an array or when you are calling a function for each element in the array. They just realized that was very common. They said, let's create this. Cool, let's think about a callback. Who can give me a callback example for the map? Oh, actually, Sergey, you have your hand raised.
My question is there a way to access the actual code of these methods? And are there any difference in time complexity between them?
That's a good question. The first part, well, the answer to those is yes for the first one. There is a way to access the code for these methods. It will be about reading the source code of the V8 engine where JavaScript runs. That has the code for that. And there's a difference in time complexity. That's another good question. From here, all the functions that we have in this red square, up until excluding sort, they all have the same time complexity. All these functions will be O of n times, O of n in time complexity, where n is the length of the array. Sort has the worst complexity here, in average being n log n, because sorting operation cannot be done in linear time. And the best sorting is n log n. From here, we can assume this sort is implemented. It actually varies per environment. Like Node have a dot sort, and Chrome has a dot sort. Firefox has another dot sort. And there might be slightly differences. We don't know which one. I think one of the most used is merge sort for sure, from the sorting algorithms that we use. And they have some other optimizations under the hood. But we can assume that it's n log n. That is an efficient sort. All the others are all of n linear time, where n is the length of the array. Good question. Cool. Who can give me a callback example for the map function? Joy?
Like you had with the for each, that same array with the numbers, you could probably map them to multiply by 2 into a second array.
Multiply. So map all the elements of one array to those elements, just multiply by 2. So let's do that. So we have our current element. This is this num. Remember, we have always the first argument is the current element, the second the index. For this, I'm just going to use always the current element, and we can return num times 2. Num times 2. Now, what does the callback itself returns?
It returns the new array.
Nope. What does the callback return?
The elements, each element changed.
That's correct. So each element change. What could we? I'm gonna call it like modified element. Modified element. And we're gonna see what that means. And as you said, Joy, earlier, so what does map return as a whole?
The new array with the altered elements.
The new array.
If they're altered, I mean, it could be a console log, but yeah,
the new array.
Yeah.
The new array with the modified elements, right? So know that compared to for each returns undefined, map will return a new array. Let's take a look at that example. So here, let's say this was for each. I comment out, or let's leave that one. Let's say let map return, and let's say nums map. Let's see what the description of map is here. Calls a defined callback function for each element of an array and returns an array that contains the results. That's sort of what we said. Now here in the argument to map, we pass in a function, a callback function. It could be this. This will be an empty function. This function is not doing anything. It's a function nonetheless. Remember, the first argument, as we saw here, to the callback is the current element and the index. Let's do current element. Actually, here, instead of calling it current element, I'm going to call it num. And let's say we want to double every number. So we return. There's a lag in my laptop. Return. I'm going to call this map. For each. And let's run this. Let me lower this here. Remember, we're still operating over this array of numbers that we had here. So let's take a look. Oh.
Check your second console log.
Oh, thank you. Map returned. Map return undefined. Let me comment out it for each. Okay, I think I had forgotten to save. The for each still running. That's why we see these console logs here. That's from this line. Let me put this here. right? So now that map is also looping over all the elements, and is invoking this function for each element in the array. Now it takes in, it's important that that function returns something, because it's going to, map will take the value that it returned, and it will store it in a new array. This array that we got here, in fact, instead of calling this map return, I'm going to call it like double array, because that's more a more accurate name. And let's say here, same thing with the function. This function we could take to its own. Let's say let double num, and I have this function there. In fact, when it's such a small function like this, let's actually first do it here. Double num. Let's save this. Execute again. We still get the same result. We get the numbers double. And here I think maybe it's a little bit more readable, where we have nums and we're mapping those numbers to and we want to double each number. So we end up mapping those numbers to a double version of them. We can map to anything, like we could maybe put all these elements in an object, and we will end up mapping our numbers to an object. In fact, we do this very, very often in React. In React, you have an array of to-dos, or you have an array of characters, and you map those arrays. You map that array to an array of li tags or of divs that then React can actually render and display to the user. So here this is our callback function. Map takes in a function. That's why it's called a higher order function. The higher the callback function will receive the number and the index. Oh, let's do this example, for instance. Let's say we have the index here, just like we also have in all the others. What if we multiply number times the index? What is going to be the end result? What is going to be the map return? Brianna.
So the number times the index, what would be the result?
Correct. The numbers are here.
Okay. Times the index.
So what would we get back here when we console log double array? Well, this will not be double array anymore, or that's just a name that doesn't describe what is.
It would be double num, right? Because we're doubling the.
Right, but actually we're not doubling num anymore, according to what this is doing.
Number times index.
Number times index.
Since we're mapping, wouldn't we get a new array that each number is multiplied by the index? So if the nums is 1 times 0, so it would be an array of 0, 2, 6, 8, right? No, 12, 0, 1, 12, and 20. 12 and then 20.
20. This is because our double num is no longer doubling the numbers, right? It's no longer multiplying by 2, it's multiplying by the index. So let's check this out. 0, 2, 6, 12, and 20. We multiplied each number by its index, right? This is just to demonstrate that we also have the index here. We could divide, we could do anything here. The sort of the key concept is the fact that we are mapping one array to an array of something else, of some modified value. Let's put it back, double num. Now, what happens if this function, if the callback function that is going into the map forgets to return, and if it only does this, let's say maybe console logs. What do we think is going to happen here?
I believe we will have an array of length, like the same length of the input one, but with all undefined.
Let's take a look at that. Cool. So first we see the console log. The console log has the double elements. But look at double array, undefined, 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 undefined. That is because we said here, map, the callback must return the modified element, because that return value of the callback is what is going to be used to fill in the return array, right? And it returns the new array. If that callback returns undefined, or in fact, let's say, if we have here, return 1, then, then here we ended up mapping our nums array to an array of 1s, right? Whatever this function returns is going to be what is used to fill in the other array, the return array, right? So if that doesn't return, as is the case when we have just console log, well, implicitly is returning undefined. And we get that undefined, undefined, undefined. When we were returning double the number, then that return value on each iteration was being used to collect it into the new array. Questions about this? Okay. So one of the main differences is, again, the map does return something. When we saw here for each, we were getting undefined as a return value. That's because for each doesn't return anything, it returns undefined. Map returns the new array. This is a new array. This is not the original array. Like we can say original array. These are array. Right? Oh, we call it nums. Our nums is intact. So nums is intact. Map returns a new array, completely new one. Cool. So let's move on to the next one. Let's go with filter. Vonil, what are the callback arguments for the filter? Give me an example, and what does the callback return?
Can you hear me?
It's kind of too low. Could you get maybe closer to the laptop? Oh, you're on your phone, I guess. I think let's try that. So what are the arguments to the callback on filter?
Filter takes in function taking I usually say element that you want to filter out. Like say you can filter through an array of specifically what you want. So an example would be if you're trying to find everything that's divisible by 2, it would be each element in the array modular 2.
Right. So I think you're telling me everything as a whole. But I'm specifically asking about what are the callback arguments? What are the things that get passed to the callback?
I guess the callback function, and also it could be an index.
So they are all the same, right? Current element, the index. These are the two main ones. There are others. There's the array is the third element, and that's true for all of them. So could you give me the example for what that function will look like here? The one that you said, let's filter out the even numbers.
So it could be num, fat arrow, num modular 2.
Modulo 2. Say num modulo 2 should equal, let's say 0 for now. Okay, so this is an example. We're going to see it in code. What does the callback return?
It returns a Boolean.
It returns a Boolean. That's important. Okay, what does the filter as a whole returns?
That thing also returns Boolean or array.
Right, it returns it doesn't return a Boolean, it returns the filter array, which is going to be a new array. I'm going to call it new, just new array. Okay, it can't fit the new filter array. Okay, so these details are important. Note here that on map, on for each, the return value of the callback was ignored. On map, the return value of the callback has to be the modified element. On filter, the return value of the callback has to be a Boolean, or anything that gets returned will be interpreted as a Boolean. And we're going to see how that is important. So let's take a look at this one in code. So with this same example, let's say, let me comment this out here. Put this here. Let say odd nums. I'm gonna call it odd nums, and we're gonna say nums dot filter. Let's see what it says here. Filter, a function that accepts up to 3 arguments. The filter method calls a callback function one time for each element in the array. Return the elements of the array that meet the conditions specified in the callback function. So this callback function that we write here, sometimes is referred as the test function. The filter will, for those elements, actually I always get tripped up by this. But let's see if I remember. For the elements that the callback returns true, those elements will be kept. For the ones that it returns false, those elements will be left out. Let me just double check that, because sometimes I just want to make sure that it's not the opposite. That for the ones that it returns true are left out. For the ones that it returns false are left out.
That is accurate.
What was accurate? The first description?
When it's true, it will return the true statements. Like that right there, anything greater than 6 characters will be returned.
Right, okay, so if it's true, it's kept in a way. That's sort of the way that I think about it. Cool, so let's take a look at that then. So here, same deal. All of these have the same, all the callbacks have the same signature. They start, the first argument is the current element, the num, whatever you want to call it. In here, I'm going to call it just num, singular. Also, I could call it current number. And the index, if I wanted the index for some reason here. I don't need the index. So when you only need one argument, you can leave the parentheses around it off because they are optional. Only when you have 2 arguments, you do need them. So we have num, and we say, for all the numbers, actually, let's do this. I think I'm liking having the function a separate variable. Is odd. And actually, it's a little bit more modularized. So if we think of this function, we can think of this function as its own thing. So let's say we're writing a function that will return true or false whether a number is odd or not. So we can say, okay, return num modulo 2 triple equal 0. Right, so we know if it return. We know that if a number modulo 2 is equal to 0, we know that it's even, right? If we divide a number by 2 and we get no remainder, that means that that's an even number. So we actually want the opposite. So let's say if it's not 0, return true. So we can try that with is odd, console.log, is odd 3. Let's try that, is odd 2. Let's try is odd 6. Let's try this, comment this out, say that, call that. And we get that is odd for 3 is true, for 2 is false, for 6 is false, for 7, true, right. Okay, so we have our simple function. This function is able to tell if one number is even or odd, returning true or false. Now we can use this function as our filter function. What we can say is, feel free to raise your hand if at any point with any questions, is filter number is odd. And let's say, let's console log here, odd nums. Odd nums. Let's try this out. Now we have from our original array, we only have the odd numbers. We have, like, more generally, we have the numbers that pass the test function. Our test function is odd. If a number is odd, then it passes the test in a way, and we keep those numbers. Also, similar to map, this is a new array, a completely new array. The original was unchanged, and this array doesn't have the same length. It doesn't have the same. It doesn't have to have the same length. Most of the time, we'll be, well, trying to remember if there's a case where it's the opposite, but it will always be less length than the original array, or at most the same length. If you end up with, at the end of a filter, you end up with more elements than the ones you started with, that means that you're doing some side effects on your function that are making it grow, that should not make it grow. You should always end up with less elements that you started with. Questions about filter? So important things to remember here. The callback must return a Boolean. We can see that here. This is our callback. This is the function that we're passing into our filter, the is-odd function. This is why filter is called a higher order function, because it takes in another function as its argument. And this function must return a Boolean. This is going to return true or false, right? If it doesn't return a Boolean, let's say it returns hello for some reason, what do you think is going to happen, Brianni?
What?
If it doesn't, if our function doesn't return a Boolean, it returns a string hello. What do you think will be our final result for odd nums?
I don't think it'll work. Maybe it'll be undefined.
Okay. So Brianni says it will be undefined. Somebody has a different opinion?
Yeah, I think it will return the original array because hello is Trudy's value.
Cool. So we have those two options. They will return all undefined or return I wouldn't say the original array, or return all the elements. Let's take a look. We end up with all nums being all the same elements of the original array. This is not the original array. It's sort of a copy of it, or it's a new array that just happens to have all the elements that the original had. And that's because what it means that this string is a truthy. So basically, all the elements in this array are passing the test, because for all of them, the callback is returning a string, which is a truthy. That says pass all the elements. What if I return 0? Hupo. Hupo. Do you hear me? Okay. Douglas, I see you have your hand raised.
Okay, I think I'm unmuted. It's here. It takes away. I'm having so many Zoom problems today. Let me get this out of my way. It should return an empty array or nothing.
An empty array of nothing.
I don't know.
Those are valid guesses. Let's take a look. Turns an empty array. This is because no element in the array passed the test. That's just because our test is very simple. We're actually not testing anything. We're just returning 0 for every element. 0 is a falsy value. That makes it so that no element passes the test, no element is returned, an empty array is returned, right? So filter just a loop under the hood that is just checking what is the result value of this callback. If it's true, I'm going to keep that element. I'm going to add that element to a new array. If it's false, I'm going to ignore it. And this is the end result. This is also very commonly used in React. What is an example in a React context application? Let's see, some of the people that have their cameras off. Let's try Owen. Hey, Owen, are you with us?
So his mic's not working?
Oh, okay. Aranza.
Yes, I hope.
I already forgot the question.
I don't have favorite one because I'm eating right now.
Oh,
yeah.
Okay. Yeah, never mind. Thank you. I forgot the question.
Okay.
I think it was you were looking for an example of how React can use filter.
That's correct. Yeah, and let's take that as voluntary. Who wants to tackle that one? What is an application that could have a filter? And I'm sure you already built also this. You built an app where you filter something.
A search function.
A search functionality, right? On a search bar, or even, let's say you want to search by color. Let's say you have a store, you want to search all the t-shirts by a specific color. We can filter our array in this fashion. Okay, so going back here, the callback to filter must return a Boolean. It returns a new array. This is an example. Cool. Any questions about filter? Okay, let's get on to reduce. As you might imagine, and I hope you do know this already, it takes in a function. But the callback arguments is interesting. The callback arguments is for this one, for reduce and for filter are different. What are anyone knows the callback arguments for reduce?
Doesn't this one have an accumulator or something like that?
An accumulator. Mm-hmm. And what's the second argument?
The current element, or I'm not sure.
The current element, that's correct. So in that sense, reduce is different. It takes in an accumulator and a current element, the callback. I think it also has the index as all the others, but in this case as the third argument. But these are the two most important ones. What is a callback example, a one-line callback example for a reduce callback? This one is one of the trickiest ones. So I'm just gonna go with, let's say we wanna add up all of the numbers of the array. Right, and I think something I forgot to mention about this is like, why reduce? So reduce, map, filter, I hope you're already starting to develop a feeling about how they're helpful and why they were created and what they do. Reduce is when you take an array. So we said filter when you just want to shrink an array to filter it by a certain measure. Map when you want to take an array and map it to something else. For each, execute a functions for each element in the array, no matter what that function does. Reduce is you have an array, you want to reduce it to a single value of some sort. So one example of the reduce will be, let's add up all the numbers of the array. That will be reducing the array to a single value. So we could do that if we say we have the accumulator first, the current element second. I'm just going to call core, and we can do return accumulator plus current. Okay. Now that this is an example, any ideas about what the callback, this function, this callback should return, needs to return? Does it need to return a Boolean? Does it need to return a modified element? Is the return value ignored? What does the reduce or the callback to reduce must return? Sharar, what do you think?
What the reduce should return? It should return one item.
On that you're correct. You should return one thing. What is that thing?
The reduced thing?
No, that's not a good name.
Okay.
I mean, technically, can it be anything? It doesn't have to be a number, does it?
That's correct. It technically can be anything. But what is the word that describes that anything, Douglas?
Is it the accumulator itself?
That's close. It has to return the new accumulator. The accumulator after you did something, after you added something to the accumulator. That's why it's called accumulator. You're accumulating something. So the callback has to return the new accumulator. New ACC, I'm just gonna call it. Okay. And what does it return? What does reduce as a whole return? This is the return value for the callback, but as a whole, what does reduce return?
The final accumulator.
That's perfect description, the final accumulator. Oops. Final accumulator. Or the last value of, or it returns the accumulator, right? But I think I like the fact that it's the final accumulator because that gives the sense that is whatever after all the iterations, whatever the value of the accumulator is last, that is the thing that is returned. So let's take a look at this. So let's comment this out. Also, the functions that get passed onto the reduce, they're called a reducer. In fact, when we saw redux, when we talked about reducers, that's still the same concept. That you're reducing your big state onto something smaller. And generally, it's about that. It's about reducing something big to something small. But in fact, reduce can do the job of all the others. Well, maybe not the sort one. Actually, yeah, maybe not the sort one. But reduce can do the job of all the other ones. Let's take a look at reduce. So let's say first I'm going to create my reducer function. Here, let's say this. Let's say add nums. So I'm going to create the callback function first. So we said that the callback function to reduce takes in 2 arguments, the accumulator and the current value. I'm going to call that, like, let's say num1. Or actually, let's call it A and B. And what I'm going to do is I'm just going to return A plus B. This is a function, simple function, add 2 numbers. Now I'm going to say let, let's call it, I'm going to call it reduce return for now. I'm going to say nums.reduce add nums. Let's see if this works. There's now console log reduce return. Console.log. Let's take a look. Reduce return 15. If this is our original array, that will be correct. Numbers 1 to 5, all added up end up being 15. Note here that then A is our accumulator, and B is our current value. If this is, I just wanted to write it like this so that we see that it doesn't have to be written here. If I write it here, it will be something like this. It will be the same thing. Maybe I'll just change the names to say accumulator is the first argument, current num is the second one, or just num. I'm going to call it just num. And I need to return, the return value of the callback function will be the accumulator that is going to be used for the next iteration. So I need to return accumulator plus num. Right? We still get the same result. This is our accumulator. This is our num. This return value, let's say, yeah, what if we do let new ACC equal accumulator plus num. I'm going to return the new ACC. I'm also going to console log here the new ACC so that we see it. Actually, let's call, let's do this. Accumulator, the number, and this so that we see the result, the new accumulator. Let's just console log these 3 things. Oops, I need a comma here. So that we see what's going on. So our accumulator, if we look at here, this is the first console log. Our accumulator is 1. Turns out that the accumulator will always be the first element. The first value for the accumulator will be the first element. We could also change that. We can specify what we want to use as our accumulator. If we pass in a second argument here, that we can see next. Right now, our first accumulator is the first number of the array. So the loop actually starts on the second number. It starts on num. You see that num is 2, is the second element. We add those two, and we get the new accumulator, which is 3. Then that 3, note how this 3 gets carried over to the next iteration as our new accumulator. The return value of the callback function is going to be our new accumulator. And that's how it sort of ends up accumulating. So that 3, this 3 was our next accumulator. Then we did that accumulator plus the current number, which is 3, then that gives us 6. And this 6 return is our new accumulator. And the current number is 4. 4 times 4 plus 6, 10. 10 is our new accumulator. We see it here, times plus 5, 15 at the end. Now, questions about this?
Don't we usually start with 0 as the accumulator?
Yeah, so let's take a look at that. So it turns out that I think we can't. I didn't put a column here for this. Oh, actually, we do have this. We have the map and the initial accumulator. I'm just going to call it initial ACC. So for the others, we saw that one argument we can pass to reduce, we can pass the function. But to map, we can pass the function and an initial accumulator. So let's take a look at that. For instance, generally, some people start at 0. So note here, this is the second argument. I'm doing comma 0. This is the second argument to our accumulator. Sorry, to our reduce. The first argument is this function, this ES6 anonymous function. The second argument is this 0 here. If we run this now, we're going to see that our accumulator will start with 0. See that accumulator starting with 0 there. Let's say we want to start from 100. That will be our first accumulator is 100. Then everything just gets accumulated with that. Oops, forgot to save. See, 100 is our initial accumulator. When you don't specify an accumulator, then the first element is used as that accumulator. This is an optional. Here's a question. What happens if I do false here? What happens if I start my accumulator with false?
I guess you will have the same result because, like, I think maybe only in JavaScript false is interpreted as 0.
Oh, that's a fair observation. Let's see. We get the same result as Amin said. False. I guess I wasn't even sure about this. Let's see. False plus 1. 1. What about true? That's correct. False, if you try to add false to 1, that is a 0. I guess this is what is known as coerced. It gets coerced to 0. It gets coerced to a number. And that's something that we have to be careful with JavaScript about automatic conversion of values. True is a 1. It gets coerced to a 1. And then we do true plus 1, we get 2. What happens if we type undefined as our accumulator? What is undefined plus 1? When with the accumulator that we currently have, or with the accumulation logic that we currently have.
It's maybe we'll break the code.
Undefined.
Not undefined. Our dear friend, not a number. Now nan, and we try to add our number to nan, we get not a number. So our accumulator, some people start at 0. Let's see questions or comments about reduce. We reduce an array to a single value. What if, let's say this example, we have an array, and we want, it's a little bit contrived, but we have an array and we want to convert this array to an object where the keys are the elements and the values are the index. Note that it's sort of flipped from an array. An array is, we have the indices, the values are the numbers. But now I want to sort of flip it in an array where the keys are the numbers itself and the values are their index. So sort of do I guess, reverse lookup in a way. Like where we have a number, we can find out what index it is. So that will be sort of reverse lookup from an array. An array, you have the index, you can get it really quickly. But if you don't know what number you're looking for, you have to search through the entire thing. Let's say an object where we have the keys be our numbers and the value be the index they are at for some reason. We could use reduce for that same reason, for that same effect. In this case, it's a little bit different where we are accumulating an array into an object. And it just happens that this object will have as many keys as elements there are in the array. So, but you still sort of reducing it to one thing. You're reducing it to one object. So let's take a look at that. So let's start with an empty. Actually, let's maybe do this here. I'm gonna call this num sum, and just so we leave this here. Num sum. Sum. And we can take a look at that. Oh, also, just note that this at nums is the same as this thing that we said here. It's just that here we call it accumulator a number, and we return the new accumulator. Here we're just doing it shorter, but here I want to copy this here. And now this is not going to be, let's call it like nums object. Let's call that nums object. We're still going to have this same thing. We're going to change a few, and now this console log just that. Console log our num object. We're going to reduce an array to an object, or turn it into an object. Nums, what did I call it? Num object. Okay, so first of all, we have, can we use our first element as our accumulators, taking into account that at the end, we want an object? Peter, what do you think?
Can you repeat that?
Do we need to provide an initial accumulator, or can we use our first element as our accumulator for this case, where we want to at the end to end up with an object?
I think we could use our first one.
Actually, we can't, because at the end, remember that we want at the end is an object. So if we start with the first element in our array so far is a number. So we can't start with that number and then turn it into an object later. We will need to start with an object here. So what I'm going to do is provide an empty object here. That is going to be our initial accumulator. Now, we can't really do this math, because if we do it, then we are going to end up with the same problem. Look, we use that as our accumulator, and the object plus 1 equal to object, and we ended up with object. Oh, this is interesting. 1, 2, 3, 5, 4, 5. But we're trying to do math in an object. That's not valid. But what we want to do is add a key to this object that we have. Add a key to that accumulator and return it. So what we're going to do here is, instead of, well, we could do, yeah, we could make a copy. It's not really necessary, a copy. Let's do this. What we can say here is, okay, we know that our accumulator is an object. So let's just create a key there that is going to have our number. And let's set that key. For now, let's set it to true. Let's just set it to true. And lastly, return our accumulator. Return our accumulator. Let's take a look at this. These are end results. We accumulated the elements of this array into an object whose keys are the numbers themselves and values are true. This is like, you remember those examples where you need to check if you already saw something in an array, for instance. This is something you could do real quick with a reduce one-liner. Convert an array into an object to fast look up to see if an element is in there, right? This will let us know if any of the elements is there in constant time. Now we said we actually want the values to be the index. So let's put the index here as our third argument. And let's try, instead of true, set the index there. And boom, we have an array where the keys are the elements, the values are the indices. 2, 3, 4. And here, this is sort of another example of, we reduce an array to a single object. So you can reduce to anything, technically. Like in this example. Questions about this? Like you could use, literally you can use this accumulator as, you can use this accumulator as somewhat of a global variable in a way. Like for instance, if we wanted to count how many odds and how many evens there is, we could use a for each, right? And just have some external variables saying odds, and then if we see an odd, we increase the count for odd. If we see an even, we increase the count for even, right? We can do that. We could also use reduce to do that, because, well, once you realize that you can pass in an object as the accumulator, and you can create keys there, then we can start with any keys that we want. We can use this sort of as our piece, in a way, as some state to keep track and to update as we go through. Here we just reduce this object to, we just reduce this array to an object where the keys are the numbers, the values are the indices. Questions or thoughts? So reduce, we use reduce when we want to take an array, reduce it to a single value. It doesn't really matter what that value is. It doesn't really matter what kind of accumulator we use. And you know, this is how, for instance, we could use. So we talk about filter, right? Did we talk about filter? We talked about filter. We could use reduce, and we could use an accumulator to implement the functionality of a filter, where our accumulator can be just an empty array. We start with an empty array, and in our function, we're just checking, is it odd? Is this odd? If it is, then add it into our accumulator. If it's not, just leave it out. So let's do that one real quick here. I'm gonna call it odd nums. Did I use this already? Odd nums, I have it here. Let's call it odd nums 2. So we have our accumulator. Our accumulator at this time will be an array, because that's what we want at the end. It's you know, something you can use to know what you want to use as an accumulator is what do you want at the end of the reduce, and we want an array at the end. So we can, because we're going to sort of implement filter with this, we can say, okay, if the current number modulo 2 is not equal to 0, what I want to do is add it to my accumulator. So I could say, because the accumulator is already an object, an array, we could do accumulator.push. Lastly, I need to return my new accumulator, ACC. And accumulator.push, what do we want to push? We want to push the number. Now let's look at this. Nums 2. Odd nums 2. Let's take a look. Yeah, we say that we basically implemented a filter, just we reduce. And this is why at some point, I remember a phrase JR used was reduce the Swiss Army knife of array methods, because you can do anything you can do with the others with reduce. Here we implemented our filter as a reduce, basically. We start with an empty array, we do the check, if so, we modify the accumulator. This is important. At your callback, you want to modify your accumulator in a way, in some way. And you must return your accumulator for it to work. Let's see what happens when you forget to return your accumulator. What do you think is going to happen when you forget to return your accumulator? Big error. Says cannot read property push of undefined. What happens is we have an implicit return here. A function without return returns undefined. And the return value of each iteration in your reduce callback will be used as the next accumulator. So that what that means is this works on the first. This works on the first iteration because we have our accumulator being an empty array. We push our number. Let's see if it's odd. On the next iteration, because the function return undefined now becomes our accumulator. That breaks the whole thing because we're going to try to do push on an undefined accumulator. And this is reduce. We're reducing, in this case, we're reducing an array to an array of filter elements, right? And we're using our accumulator. We're using an object, an array as our accumulator. So we could use anything as our accumulator. Questions, thoughts about reduce? It's the one. It is the most mind-boggling one. It didn't click to me for me until I experimented more with it. Let's see. But here, going back, reduce takes in a function. Oh, actually, I wrote this in the wrong place. The initial accumulator is the second argument to reduce. Initial accumulator. The second argument to reduce. The callback arguments are the accumulator and the current element. This is an example. The callback must return the new accumulator or the modified accumulator. Lastly, it returns the last value that accumulator ended up with. That will be the return value of our reduce function. So notice how, yes, they're all array methods. They have similar callback arguments, but there is some difference about what they return or what the callback must return. Questions, thoughts? Okay, I think let's just see every and sort, and that'll be it. We can talk about the slice and includes, but we don't need to see it. Every, what is the argument that we must pass to that every? Kathy, what do you think? Kathy, are you with us? Where is this? Okay, maybe she's not with us. Chuck. Wait, actually, I already called on you. Khadija.
Yeah.
So we're talking about every. What is the argument that we must pass to every? To that every function?
Every element in the array has to pass whatever the argument is, and it'll return a Boolean.
Okay, so wait, so you told me everything at once. So this must return a Boolean, that's correct.
Yeah.
The callback must return a Boolean. But even before we go to there, when I call that every, what do I need to pass to that every?
The parent element.
Not the parent element. Look at what we have in this column here. This column. What do all they have in common? What do we pass to all of this, guys?
Argument.
Right, and what kind of argument? What do you think FN stands for? Function.
Oh, a function.
We pass in a function to all of this. They are all higher order functions. That's why they receive a function. Now tell me about the callback arguments. What do we pass to that function? To the function we pass to every, we need to pass
We pass that the current element.
Current element as well. Have the index as well. Most of the time we leave it empty. And you mentioned something about a test. Tell me more about that.
So it could be like I guess numbers. Like if each number is even, then it'll return true. If each current element in the array is even, it'll return true.
Right, that's correct. So let's do, I'm just gonna write here, same as filter. Cool, thank you, Khadija. So every, similar to filter, takes in what is known as a test callback. As opposed to filter, well, actually, before we go to there, what does every return as a whole? Does it return a new array? Does it return an accumulator?
An array.
Nope, does not return an array. Somebody can help Shar?
It returns a Boolean, true or false.
It returns a Boolean. It returns true or false. So it's similar to filter in the sense that it takes in a test callback. It's going to call that for every single element. And only if every single element passed the test, it will return true. If one of the elements failed the test, it's going to return false. See a quick example here. We have our, let's say, let all nums, let's say, and we can say nums dot every. I'm gonna call it num. Is every num a type of num triple equal number? This is sort of a simple one. Let's do console log all nums. Let's see what this is going to return. All nums. Oops, I think I still have this error. All nums returns true. So we see that the return of the every func call of the every array method is a Boolean, as we have noted here, Boolean. The callback must return a Boolean. This is here we're using ES6 implicit return, right? You should be familiar, very comfortable by now with ES6 implicit return. If we don't use the implicit return, we need the curly brackets. We need to do return. Yet the same thing. This is sort of checking, is every number in our nums array of type number. If we put in a string, let's put in 6 at the end, where the type of this is going to be a string. We try to run the same test. False. Because not all of them are numbers now, right? Only the first 5, the second one is not. So not every element is a number, we return false. This is another example. We could write this with reduce. Our accumulator will be just true or false, and we're checking if it's a number. If it's not a number, turn it into false. Use that. If it's a number, keep it true, and so on. Questions about every? Oh, I think there was one that I forgot to include here, which was find. And every, it uses the same as filter. It uses a test function, text callback. That callback must return a Boolean. If you return something that's not a Boolean, that will be coerced to a Boolean, converted to a Boolean, and taken into account, and it returns a Boolean as a whole. Sort, for the last one, takes in a function, not surprisingly. It doesn't take in the current element. It takes in, wait, actually, let's take a look at the documentation real quick. It takes in num1 and num2. Sort. I'm not sure, I don't think it's current element. It depends on the sort. Okay, so we see that array sort takes in a compare function. Oh, first of all, this is optional. You see how it has square brackets? That means it's optional. This array is sorted already. let's make it unsorted. Let's do 3, 1, 2. Maybe 0 here. So if we can just do console log. Oh, this is also important. Let's say sorted equal nums.sort, just like this. This console log sorted to see that. Sorted, we have it sorted in ascending order. That is because that is the default. This operation there took n log n in time complexity about. Now, also, let's take a look at this. Console log our original nums. So this is something that is important to remember. None of the other ones modify the original array. None of the other ones changed num, but sort did. Sort modified forever an array, and it modified it, it sorted it. So that this is known as like sort in place. The sorting took place in place, and nums was modified to be sorted now. Nums does not return a new array. In fact, if we take a look at this, sorted triple equal nums, sorted triple equal nums, we should get true, because the thing that nums.sort returned was not a new array. You could think of it as a pointer to our original array. That is the sorted, and that's why we can compare. In this case, we're not comparing like if the elements are the same. We're comparing, are these two pointers the same? Are these two things pointing to the same thing? Is sorted pointing to the same thing that nums is pointing to? We get true. They are both pointing to the same location in memory where this array is stored. So that's something to be mindful of with sort. It modifies the original array. If you don't want it to modify the original array, you need to make a copy beforehand and let it modify that copy. Cool, but you can see here that to sort, we can pass a compare function. What if we want to sort in the reverse order, for instance? We want it, this is ascending order. What if we want it descending order? So we can specify a compare function. That is our callback. That's a callback we can use here. So it specifies a function that defines the sort order. If immediately the array elements are converted to strings, then sorted according to each character Unicode point value. Oh, this is interesting. I didn't know that each element is converted to a string and then compared by its Unicode code. The first element for comparison, the second element for comparison. So as opposed to the others, the callback argument is the first and second values as first element, second element, and they don't really tell you whether that's the current element or what. So I'm just call it A and B, and let's keep reading what we have here. The return value. The sorted array, know that the array is sorted in place and no copy is made. Compare function. So let's take a look at here. If compare function AB returns less than 0, sort A to an index lower than B. I think this is the default. If we, let's see, return A smaller, no, wait. this it has to the callback function. I think I'm. Yeah, let's go back here. The callback function, the return value must be a number. And that number is 0, 1, or -1. So we see here, if it returns less than 0, well, it actually doesn't have to be -1, 0, or 1. It can just be anything less than 0, greater than 0, or greater than 0. If it's less than 0, sort A or put A to a lower index than B, saying A comes first. If it returns 0, leave A and B unchanged. Don't move them around. If it's greater than 0, sort B to a lower index than A. Right. So if we a note here, the compare function must always return the same value when given a specified pair of numbers A and B as its 2 arguments. If inconsistent results are returned, then sort order is undefined. So keeping that in mind, oh, here, let's do this first. Let's console log, let's console log A and B. Let's always return so let's return 0. See what we get here. Okay, so we said that if it returns 0, leave them unchanged. That's what we have here. Do we have? Right, the console log will be this. The first number, the first comparison is comparing 3 to 2, 2 to 1, 1 to 4, 4 to 5. It's just that it's not doing anything with it. We said we wanted to sort it in reverse order, in descending order. So we said if it's 3, 3 is greater than 2, and if we said we wanted to return, we want to put 3 at a lower index than 2. So we said if it must return, so 3 is A, 2 is B, return less than 0, sort A to an index lower than B. Right, so here we need to return less than 0. So what we can do is, let's just return term B minus A. Term B minus A. This should let us with these are same as our original one, right? Oh, I forgot to save. So we see that if we return B minus A, keeping into account that the compare function, if it returns less than 0, is going to put the first number A to a lower index. If it returns 0, leaves them unchanged. If it returns greater than 0, is going to sort B to a lower index. We see that then we are able to reverse sort the array in descending order in this fashion. And we can see here the ordering which happened. You can actually see that there's more comparisons now. That is, on the first iteration is comparing 3 and 2. It's comparing 3 and 2. 3 will be sorted to a lower index. Then it compares 2 and 1, and it depends, I think it will depend on what sort this is actually using, that we could figure out what, how it's actually happening. But we see that A was used as the second element. But that breaks around here, for instance. At some point it picks up 3 again, and it compares 3 to 4. Actually, what if we console log A as well as nums? Can we see the sort happening? Yeah, we can see the sort happening here. So 3, 2, then it moved here. Then it's not just swapping them as bubble sort. it sorted one to a lower index, so it moved that one. Wait, no. 2 and 1, it keeps sorts 2 to a lower index, so it doesn't do anything. It just keeps them there. Then you move to 1 and 4. It's going to sort the greater to a lower index. Oh, this is interesting. 4 gives, we get double ones, and 4 seems to have gone somewhere, but it comes back here. Anyway, we don't have to get into all of this. This is sort. So we learned that sort can take in a callback function. That callback function gets 2 numbers. The first and the second one. This, I'm actually going to say A and B. Let's put an example here. A, B, A, or actually B minus A. The callback will return a number. That number can be greater than 0, 0, less than 0. It returns the original sorted array. Cool. Questions in general about this review we did? Raise your hand in Zoom. Okay. Slice instead of all the others, instead of taking a function, they take different arguments. I think slice takes in a start point, start index, and an end index. Well, the callbacks, this will not apply to any of them because they don't take callbacks. It returns the slice array. Takes in a start and an end. Start and an end. Includes, takes in just an element, and is just going to triple equal check if that element is in the array. Includes, maybe this could be the last example we look at, the includes one, just because there is some other JavaScript that is important to sort of review there. Splice is similar to slice in the sense that it can, but splice can also add elements to the array at any point of the array, where when you do push, you can only add at the end. Slice can let you add at the middle, can let you remove and add at the same time, which is also what makes it a little bit complicated to understand. The splice is able to do 2 things in one. Join just turns them into an array. It turn it into a string. I think let's just look at includes, just because I think it's a good example. I think I actually have it here. I think I might have that. Where did I put that? My desktop. Here it is. Let me find it here. No, never mind. It's finding a lot of includes. I didn't know there was so many things called includes. But I think I want us to look at this one just because it's, so let's say we have our nums array. Here, we could just do it like with a few console logs. And say nums includes, and here, let's check if our array includes number 4. Node array methods. We have true. It includes number 4, right? Includes any of the numbers that we have here. This is just looping, checking if one of them is equal to that. This is an important scenario where we have, let's say, I'm gonna call it array, say 1. Say an object with a key of A. Let's say true, undefined, or null. This is 0. If we run this into our array, we should get false because this array does not include false. Also I'm going to say let call it object dog name Pluto, and let's also add this maybe here. Just add a dog here. Now, so once we run this, we see that false because 4 is not included in an array. You may be tempted to do this. I want to see if this array includes an object with a key that's ABC. Is this going to return true or false? This might be a question you get in an interview, especially a JavaScript interview. Let's do a poll here. And if you go to the participants, say yes if it's going to return true. Say no if it's going to return false. Okay, I see 2 for about 6 no's saying it's going to return false. A few yes. More no's coming. Where is everybody else? Pick one side. It's going to return true or false. Okay, so it seems that we see that there are more false. More people think it's going to return false than true. Let's take a look. We run this. Say we see it returns false, and it's important to understand why it returns false. It returns false. So when it's a simple value, when it's a primitive, that's what I should say. When it's a primitive value, like null, what every is doing is, let me comment out this stuff here. When it's a primitive value, it's looping, checking if the current value, element, this is still just a loop. It's checking if the current element is equal to the one we passed. No, and it's doing that with triple equal. It's like, if you write this in a loop, it will be, the regular for loop saying, if current element triple equals the element that got passed in to check for, then return true, right? So when it's a primitive like that, or if it's true, it's just doing that comparison with the triple equal. Now, when we pass in not a primitive, but we pass in an object, even though this object has the same structure as the one that we have in the array, they are different objects. They are two separate objects in separate parts of memory. And the triple equal comparison is still happening. But the triple equal comparison for non-primitives will only be true if they are pointing to the same thing. So here we have this object that we created here. And we have this other object. This is a completely new one, different copy of the object. They have the same structure, they have the same values, they have the same keys, but they are different. They're in two separate places in memory. Then what this is doing is checking if this is equal to that with triple equal. Is it equal to? No. Then it checks if this is equal to this. And it's not checking the keys and the values, it's checking the pointers, it's checking the place in memory. Is this the same pointer? Are these two things pointing to the same thing? They're not pointing to the same thing. They are in separate places in memory. We get false. From there, it just checks on all of it to see if it's if any of the other things are what we want here, and we don't get that. But now let's take a look at dog. Dog is here, we declare it here, and we have an object. So you can think of it like for objects and arrays, you can think of just pointers. Like you have dog, that is a variable that's holding a pointer to a place in memory where the object is kept, right? And it's just that we say, oh, in the array, we want to include that pointer to the dog object. That thing that is pointing to the dog object. Now here, we're just going to check, oh, does the array include the dog? And it's the same dog. You can think of it like these two pointers, this dog here and this dog here, are pointing to the same place in memory where this information is stored. And there's only one. If we run this, we get true, because now the comparison, we're comparing this dog to everything, and at this point here, we're comparing, is this dog that I have in the array, this pointer that I have in the array, pointing to the same thing that the dog that came here is pointing to? And they are pointing to the same place in memory. So that's important to know about sort of pointer equality, or just comparison of values in JavaScript. We know that if we say empty array is equal to empty array, false. Even if it has one element, false, because this array was created in some place in memory, and this other array was created in some other place in memory. They're pointing to different things. They're not pointing to the same thing. We do let A equal array 1, and let's say let B equal to A. So now A is pointing to this array, and B is pointing to the same thing A is pointing to, which is this. And we say let A triple equal B. Unexpected token. Oh, no need for let. True. You have two variables, two pointers pointing to the same exact thing. Cool. So that is pretty much it. Everyone, any final questions about this review that we did on array methods? Okay. Let me launch this poll. So if everyone just could take that time to answer the poll. Okay, so for the remaining time, what I want us to do is just to practice some of this. In Canvas, I added the lab that we did back then. I would suggest if you're still not feeling very comfortable, just get through the lab again. If you are feeling comfortable, there is these other exercises here. So these exercises are like the array methods lab. If you feel like you're still struggling with the basics, just go look at this again. Try to do some practice of that. If you're feeling comfortable with that, there is this kata here in Code Wars that I can, you go on Canvas and look at it. That has some other examples where it uses a little bit more like of real data. It does that with like an array of developers, and they have name, they have country, they have like language, the language they code in, and you have to sort of draw different conclusions based on that data as an array of developers. So you can say, yeah, count the number of JavaScript developers coming from Europe, for instance. Great developers, say, find the first Python developer, and stuff like that. Where this is more like what you would do on a day-to-day basis at work, like actually dealing with real data, sorting through it, filtering, mapping, reducing, etc. So that is my recommendation for you. If you're feeling comfortable, tackle these exercises in the kata that are available in the Canvas calendar as advanced. If you're struggling or still not very sure about the basics, just go back to the basics and look at the examples that we have here in the lab. And I'll be here for anyone that has any questions. Yeah, I guess we'll see you in the afternoon. Keep working on your capstone projects for the afternoon, but for now, like from here to 1, my recommendation is you go and check these exercises on array methods that we have, especially now that we have it a little bit more fresh and knowing that I'll be here. So that's it, everyone. Let me know if you have any questions. Cool. See you in the afternoon. I'll be here. Amin?
Yes. I have a question about like when you said now about databases. So is it better to have all the information and then do like one of those filters, or create separate query for this to like have only the information you need from the database with the query?
Yeah, it's my inclination is that it's better to do the filtering in the query itself rather than getting all the information and querying sort of in Java and filtering in JavaScript land. I don't know I feel like the database might do some optimizations that I just don't know about because I'm not a database developer and I don't really know how they work under the hood. So I'll say if you can do most of the operations you can do in SQL rather than JavaScript. Only when it gets too complicated is that it's sort of that you can come back to JavaScript land and then maybe do 2 queries and stuff like that. I remember when I was a fellow I remember I had this complicated query. I don't even remember what it was about. And I remember that I needed to make 2 SQL queries in JavaScript. Like after one, I'll make the other one. And I was sure that there was a way to do it in SQL, just in 1 query, but I just couldn't figure it out. And I was looking into how to create like SQL functions that will let me do that. I never really figured it out. I ended up just having those 2 queries in JavaScript land. And I remember I went to my instructor saying like, I feel like this could be just done with a 1 query. But I feel like I'll need to learn how to create a SQL query to make all this logic possible. And then he said that it was okay just to have the 2, like for those complicated cases where the query is sort of, I guess, asking too much of us as web developers knowledge in SQL. It will be fine to just leave it in, to just have those 2 queries in JavaScript. But my recommendation is just test yourself how far you can go in SQL. When things get complicated, it's okay to fall back on JavaScript to help you with that complexity.
Thank you.
Cool. Yeah.
Thank you, Alejo. See you later.
See you.
Have a good day.
Thanks, Alejo.
And thanks for this. We're not outside of our 5:45. There's not an official second group regroup today.
Well, I think there should be. I guess the 5:45. Yes, 5:45.
Okay.
That's the one.
I know I've got a technical training or mock interview at 2, but.
Got it. Oh yes. Wait, no, that's at 4.
Oh, is it 4? They get moved?
Or I don't know. I know that you have one with me at 4.
Okay, cool.
Doing something.
No, it may have, I may have old news. Okay, that's absolutely fine. Let me do some quick fixing of my schedule. But again, thank you for this time and thank you for this lesson. It's been very good.
Sure. Yeah, glad to hear it. I'll upload the video in a little bit.
Cool.
Okay.
Thanks, Alejo. And I'm sorry if I sounded rude earlier when you picked on me.
No, that's fine. That's understandable if you were eating.
Yeah,
I didn't
you
even
didn't
finish
know
my
that, so I'm so
breakfast.
sorry.
That's fine.
Like that stayed stuck in my head, so I'm sorry.
Nothing to apologize about.
I'll see you guys later.
See ya. Hey, Winter.
Hey.
How are you doing?
I'm fine. How are you?
I'm good.
That's good.
Yeah. Oh, so I talked to, I messaged Ben and Jimmy about the CTA, see if they were building like a reassessment assignment. They're not.
I know. They said they wasn't.
I feel like, yeah, I guess I didn't get that. So wait, let me stop this recording.